So I'm guessing a lot of you probably have already started this problem, and I suggest that you write it down. There again, there's perhaps some abbreviations up there that, unless you follow a football of some sort, might not make any sense. But anyway, how much energy does a defensive tackle place into a running back that is moving at 3.18 meters per second and has a mass of 145 kilograms? So what would happen if I said is moving at this 3.18 meters per second and then changes to 0.107 meters per second squared? Would that have anything to do with this problem? That second number we gave you, 1.07. Because when you measure something in meters per second squared, okay? So, so again, if this was placed into the problem as well, 1.07 meters per second squared, which one of those numbers would you use? And that's right. Why are you right, though? Yeah, because if it's meters per second squared, it's an acceleration, not a velocity. Okay, so then as we continue to proceed forward or moving on, you've read the problem. The next thing to do is what? Okay, so what do we know in this problem? So we've got 3.18 meters per second, and we've got 145 kilograms. Okay, so this just reminds me, remember I said yesterday, one of us was going to be happy today, one of us was going to be, I'm not totally upset. It was still a good game to watch. Yeah, I know. I agree. We don't have to read it. I'm just kidding. But I just thought of this problem. I want to say, oh yeah, they still scored a touchdown, but there was a right, maybe a defensive end for Seattle or defensive tackle. I can't remember. That, what's his name? 25 for Minnesota. Something Madison. He was a running back. Okay, Alexander Madison. I think one of the plays, they're going to try to do a power to the left, but no one blocked this defensive tackle. I just remember he just got leveled. So that's kind of what this problem is based off of. And how would we know that this is kinetic energy instead of potential? Well, for one, we haven't learned potential yet. But when we talk about kinetic, it has velocity in there. So if it has velocity, that object is doing what? It's actually moving. So it's going to be doing one of these aspects. Yep. So then moving forward, once you have this information down, okay, let's do what the formula tells you to do, which it's saying we're looking for KE, or kinetic energy. And so since it's moving, that's when it has this kinetic energy. Now, I'm not a deer hunter, but that's a pretty good example of how different types of energies can change. So if you are a bow hunter, okay, what two types of energies do you suppose you're dealing with? Obviously kinetic, because that arrow is going to be moving, but when you draw that string back, you're storing lots and lots of what? Well, potential, but it's still going to have momentum too, but we just haven't got it back. And the more, how do I want to say it? So you got the gears up on top of your bow. I know they're called compound bows. I'm asking because I really don't know, the more that you have up there, the more tension that's what you have on there, right? Do you ever get to thinking that I really don't need to have this bow that has that much tension on it? Is that a logical question? Okay, and that's probably just a regular bow that you find in medieval times, right? So that's just wasted money, right? Yeah. Okay. Okay. So, I'm not a deer hunter myself, and I get it. Some of you might be listening to this and thinking, I could not care less about deer hunting. But sometimes, I really think when it comes to learning this material, if you can actually visualize that happening, it makes it easier to understand. Now, are the problems always going to be accurate? Well, no. We're maybe not that good at writing some of these problems. But in this case, once you've got it to this point, okay, what does it tell you to do? To set the kinetic energy equal to what on the right-hand side of the equation? We got the left side. Okay. How many of you like the 1/2, and how many of you like it all over 2? And I think that's probably an easier way of looking at that. Okay. So you said all over 2. Okay. So what goes on the top of that fraction? Because a lot of you said it. Mass times velocity. So we've got 145. Okay. And then times velocity squared, which is 3.18. And don't forget to put that little 2 up there. Okay? So, but as far as when you solve these, when's that taught that you do your powers, parentheses, division, multiplication before addition and subtraction? Right. Do you learn that in junior high, or is that something that's unique to you this year? Okay. So, to me, I don't think it matters whether this is on the inside or the outside. Maybe it makes more sense to put it on the inside. But to me, what would make the most sense is take that 3.18 and double it right away. But when we say double it, okay, we're just taking it times what? Yeah, we're taking it times itself. Don't add it. Those are obviously 2 different functions. Okay? So when you take 3.18 times 3.18, we get what? And times 145, sorry. Okay, E equals 10.11. Is that correct? Okay, well, we'll stop there. Don't forget, it's all over 2. So once we divide that in half, then you get your energy then. Okay? So just a little over 5. Just slightly over 5. Oh, okay. That's not a lot of energy. Okay? So 10.11 times 145 gives you what? That's what I was asking earlier. 65 point. Okay, whatever. You said 1,000. Okay, I didn't do that right. 1,000 for. Okay. Whatever it is you get when you multiply those 3. Okay? 1,460. Okay. Okay. So then once you divide that by 2, you get approximately 733. Okay? So KE equals 733 point whatever. Okay? So since it's energy, it's labeled in what? It's labeled in joules. Okay? All right. Left middle, are we good? Right outside, are we good? Right outside. Okay? Middle. Left outside. Right middle. How we kind of mix that up a little bit rather than just see if we catch anybody sleeping. No one's sleeping. Doing some head bopping. Singing along to the beat, are we? Oh, okay. Well, no, am I singing along to the beat? Oh, okay. I can't carry a tune anyway. Okay, so as we continue to move forward, okay, one of the things we learned yesterday, well, we'll catch up to you next time.